Welcome. We're starting a new unit, Unit 11, and now we're going to be talking about quadratic equations. All year long we'll be talking about equations. We'll be talking about linear equations, and we use y equals mx plus b. In this case we're going to be talking about quadratic equations. Linear equations, always when you graph them, gave you a straight line. In this case, quadratic equations are going to give you what we call parabolas. There's a curve. It's either going to be going down as a frown, or it's going to be going up with a smile. So let's get started. First, you're going to be on page 1 of your notes packet, and there's a couple of things I want you to fill in the blanks for. Number 1, we're going to talk about the standard form. All quadratic equations are written in the form of y equals ax squared plus bx plus c. This is your quadratic equation. Notice that the first term here has an x squared, and that's where the curve comes in. When graphed, a quadratic equation creates a U-shaped curve called a parabola. There's two types of parabolas. If you use your graphing calculator to sketch the following, the first one, it looks like this. So if you notice the curve here, and I'll do it with a red pen, it's going up. Okay? This parabola is called a minimum, or it has a min. That means the lowest point, the lowest area, is a minimum area. This area is also called your vertex. And then over here on this parabola, notice it's going in an upward direction. And so in this area it has a maximum height or maximum point. So please make sure you're filling in your notes. This parabola has the vertex is up top because it doesn't go any further. One of the things you'll notice is on your quadratic equation that if a is positive, then the parabola opens up like a smile. But if a is negative, then the parabola opens down like a frown. Other things that we're going to talk about is called the axis of symmetry, and then the vertex. The axis of symmetry is the vertical line that divides the parabola into two equal parts. Two equal parts. And so notice it is looks like a dashed line that you put between the two equal parts. The formula for the axis of symmetry is x equals negative b over 2a. But we're not going to worry about that in this class. I'll show you a nice, easy way to get that. Then we talked about the vertex. Understand the vertex is either the lowest point, which is called the minimum, right here, or the highest point. It is also called the maximum. This is the area where the turning point of the parabola is. It is understood or understand that it is recognized by an ordered pair. So the highest point or the lowest point of your parabola is called your vertex. And you'll be able to see how to find those in your calculator. An example. So here you got the first example, which is the bottom problem of your packet. It says y equals x squared plus 8x plus 15. So if you go in your calculator, turn your calculator on, go to y equals, and type in your quadratic equation. And I hope you can see mine. It's x squared plus 8x plus 15. And then you're going to hit graph. Notice there's my parabola. So looking at the parabola, do we have a maximum or a minimum? In this case, we have a minimum. So because of that, we're going to find out by hitting second and trace. We're going to calculate the minimum. And then on the left bound, you're going to hit the cursor to the left of your parabola. So notice I'm hitting the cursor. You see the cursor moving to the left side. I hit enter. Then the right bound, I'm going to move it to the right side of the parabola. And then I'm going to hit enter, and I want it to guess, so I hit enter a second time. So notice it says here my minimum is -4 and -1. So I can actually move my graph here to -4, -1. And it says my vertex was -4, -1. We had a minimum. And the axis of symmetry, I'll show you, is where it crosses, it splits this parabola in half. And the axis of symmetry is where this line crosses on your x-axis. In this case, it crosses the x-axis at -4, so we say x equals -4. That's your equation of the axis of symmetry. Hopefully this has been helpful, and we'll talk some more with the examples in class. I believe that is it for today.